RSA cryptography is the basis for encrypting computer storage, for encrypting internet transactions such as occur in banking and purchasing, and for communication privacy in general. It was discovered in 1977 by Rivest, Shamir and Edelman at MIT, hence the name RSA. But in fact it had been discovered 4 years earlier by Clifford Cox, working for British intelligence, but this fact was not made known until the 1990s. RSA cryptography is almost unbelievable at first, unbelievable that it could even exist. It essentially works as follows. You publish a large 300-digit number, say, which is the product of two primes. Only you know the two primes, but the number itself is made publicly available. Using this number, anybody who has a secret message for you can encrypt it, and they can then publish the encrypted message, but only you can decrypt it, and that's because you know the two prime factors used to obtain the large number in the first case. Security agencies are not very happy about this, and in fact the method was banned from export from the United States, and there was even a court case in 1993 charging one person with export of munitions. The charges were dropped 3 years later, and this was despite the fact that the method had been published in Scientific American in 1977. In the following, I will begin with some simple examples of encryption and decryption, as used in fact by Julius Caesar 2,000 years ago. Then I'll say a little bit about working with large numbers, because we're going to need quite large numbers, 300 digits say or more, when we're using RSA cryptography. Next we'll talk about the implementation of RSA cryptography. Then a couple of examples. The first will be a real example in the sense that we'll be using large primes, 150 digits or so. And then a toy example, very small prime numbers, to perhaps get a better idea of how the method works. And finally, I'll talk about the mathematical theory of RSA and prove the RSA theorem which justifies RSA cryptography. Now, except for this last section, you'll need very little mathematics. You'll need perhaps just a basic understanding of primes, modular arithmetic, and the notion of greatest common divisor, and that's it. However, for the last section, we'll use Fermat's little theorem. And even if you found the proof confusing, try and understand the statement of Fermat's little theorem, then that will be sufficient to go through and follow the proof of the RSA theorem.